Black math! Give me some math and I'll give you some flack. Black math!
All right, here we go. Oh yeah, so we haven't talked about our special triangles yet. Like we just talked about it in Algebra 2, but we're going to talk about special triangles. So this is the 45, 45, 90 triangle. Okay, so this is obviously a triangle that has 45, 45, 90 degrees. So it's a right triangle. So these guys are 45s. So that means, what do you know about these two sides, Tori?
What about them?
They're equal.
Yeah. So if these two angles, so these are got to be the same. So if this is 7, you can find the rest of it. The other one is 7. So how do you find this side?
Can't you just a squared plus b squared?
Yep. So let's do that.
49 plus 49 equals what? 98. 98 squared is 9.
Square root of 98 is not 9, but
No, it's not. You're right. Actually.
okay. But you can reduce this radical, right?
Yeah.
What square goes into 98? We just figured it out.
49.
49 goes in 2 times, right? So this is the square root of 49 times the square root of 2, so 7 radical 2. So that's what C equals, right? Let's try another one. Another 45, 45. Let's say this is a 3. So what are you going to get here? A squared plus B squared equals C squared.
So 9 plus 9 equals 18.
Let me guess, it's going to be 3 radical 2.
Yep, this you can take a 9 out and a 2 out, so 3 radical 2. What's the shortcut?
You know, it's going to be this radical.
It's just going to be whatever this side is times radical 2. That's the shortcut. So on a 45, 45, 90 triangle, if this is x and this is x radical 2. That's pretty easy, right? Now, here's the deal. You don't have to understand why. If you can just remember the shortcut, you're good. But do you have to remember the shortcut? No, because you could just use the Pythagorean theorem. Pythag it out. Okay? So this is great because if I give you just an example of this, you can tell me the rest. So tell me what x and y are.
X is 2 and y is radical 2.
Okay, let's raise our hands so more people can be involved.
I don't think I've
So what's y?
Can I just answer? Because someone's raising their hand.
Well, you're raising your hands.
Sure. 2 radical 2.
What is it?
2 radical 2.
2 radical 2. That's right. Okay, does that feel all right? Okay, now the only way this can be tricky is if you have to go backwards. So here's example 1b. What happens if you're given this side?
You just have to actually like map it out.
Yeah, so how do you go backwards? Well, what did you do? What does it mean when it's right next to each other? It's times, right? So how do you go backwards from here to here? You divide by radical 2. So what is this going to be? 3 divided by radical 2, right?
Yeah.
Okay, can you have a radical in the denominator? Did we talk about this? So this is, you can't have a radical in the denominator, so what do you have to do?
Make it, you got.
Do you remember how to get rid of that?
Flip, right?
Well, not flip, but
Reciprocal?
no, we didn't talk about this then.
We
Okay.
did an algebra 2, so I should know this.
I also know this.
You tried to blot that out of your memory. You know those times in life where something tragic happens and you can't remember it?
How it is.
That's algebra 2. Okay, so how do you get rid of a square root?
Sure.
Square it. So if I multiply this by itself, that's okay as long as I do the same thing on the top. What is radical 2 squared?
1,
Radical 4.
2.
Radical 4, which is?
4.
Square root of 4, which is 2. So basically, when you take a radical times itself, you're left with whatever's underneath the radical. So radical 7 times radical 7 is just 7.
So it's 1.5.
Okay, so you get, and then your top ends up getting all the junky, I'm using green. I'm sorry, Maddie. One more green, okay? So you multiply by radical 2, radical 2.
I can like hardly ever see the board in general. So I kind
Well,
of
when I rewatch the videos.
Oh.
Okay, so
Maybe I
look
should
at guys. See how only reason we did this is because we have to have a pretty denominator. We don't care about the numerator. The numerator can be as ugly as we need it to be. We just need a pretty denominator. You can't have radicals in the denominator. So to get rid of a radical, you multiply it by itself. And it gets rid of it. It turns into a 2. But whatever you do to the bottom, you have to do to the top. Otherwise, this is not the same value as that, right? Because this is just multiplying by 1. Same thing over itself. You're just multiplying by 1. So you end up with 3 radical 2 over 2. So here's the shortcut. To go backwards, you still tag on a radical 2, but then you divide it by 2. So the backwards, it doesn't really make sense that way, but to go backwards, you're still tagging on radical 2, but then you put it over 2. So real quick, let's apply the shortcut. If this is 11, what's this?
Oh, it's 11 radical over
11 radical 2 over
radical 2
over 2.
over 2.
So that's me already getting rid of the radical.
Oh.
So you could just go 11 divided by radical 2.
That's what I was doing.
Okay. So what if you have an even number? What if this was a 10? What's this going to be?
It's a, oh wait, it's a
10 radical 2 over 2?
yeah.
Yeah. But then,
But
what
then
does
it
that
can
equal?
reduce. It's 5 radical 2.
Yep. Okay. So all you're doing is multiplying by radical 2 and then dividing everything by 2. And obviously you can't divide the radical by a normal 2. You can only divide radicals by other radicals and rational numbers by other rational numbers. So this, you just have to leave it ugly. This one kind of makes it a little more attractive. Okay. So far, so good?
No.
So that's the 45, 45, 90 triangle. So like a question on your homework might be some problem like this, and then it's going to say find the perimeter. So yeah, you have to find each side. So here's example 2. So it's going to say 45 degrees. It's only going to give you one angle because it doesn't want to waste ink. And then it says find the perimeter. Find the perimeter of that.
Okay, well, you know that one's, the other one is also 12, so it's 12 squared. No, that's your area.
So what do we have so far on the perimeter?
18 radical 2.
18, you need 24?
So
No, I was saying the answer. 18 radical 2.
no.
So you
What do you have
24.
so far? Don't get ahead. What do you have so far?
24.
24. You have 12 plus 12. And then what's this side?
12 radical 2.
12 radical 2, right?
Oh, yeah.
All right. Now what do we do?
Add like terms.
Yeah,
So
you
it's
only
24
24.
plus 12 radical 2.
And that's all you can do. You have to leave it like that. So remember, you can only add radicals with other like radicals. They're kind of like variables. So you're adding like terms. Okay, now if it said, I want to cover that in something around the edge, then this doesn't work at Home Depot, right? So what would you do? How much
What was the
fabric?
question?
I want to wrap fabric around it. How much fabric would you need? Well, a radical 2 doesn't work at Home Depot. So grab your calculator. Radical 2 is approximately 1 point something, I don't know. So just on your calculator, and you could do this. I'm going to say inches, even though the example says yards. So what's radical 2 times 12? So what's that?
It's like 1 point something, so it's like. Wait, how much is a radical?
Radical 2 is 1.41.
Okay, so multiply that by 12,
That's not long.
and then add 24. And what do you get?
40.97.
All right, 40.97 inches approximately. So make sure you do the wavy equal sign.
On a
Okay.
test, will it usually be like?
It'll say keep it in terms of radical, or it'll say
use-
round it to the nearest hundredth or something.
Okay.
Okay. So far, so good? Does this feel all right?
Yeah.
I like these triangles because you don't really have to do too much math. You can figure it out by if you remember the shortcut. But remember, if you don't remember the shortcut, you're still fine. It's just going to take a little longer because that's what shortcuts do. They save time. All right, so let's do this. How about, here, I'll modify this one a little bit. So find the area. Example 3, find the area of this triangle. Find the area of that right triangle. Okay?
In like what should the solution be?
Wait,
It's the area of a triangle equals half the space times height, right?
Yep.
Okay, so half of.
Well, we don't have base, or we have to figure out the base.
Wait, isn't it the long one? The big
Yeah,
one?
but we only have one measure. We'd need a height too. So we need like it's I don't want to do this.
Well, base and the height are the same because it's an isosceles triangle.
Wait, so half its base.
See how if you choose the top
It's
side.
it's 125 over radical 2. And then you do
What is
the
half?
So let's round it to the nearest hundredth, okay?
600?
612. So
yeah, but we'll half it at the end, won't we? Because we have because that's not the area. We're finding the area. That's only one side length, so we have to find out the other side lengths because we don't know.
wait,
that.
is the
On
half
both
of it?
sides, but we only got the one that's not the same.
Tori, is the half of it 62.5?
We don't need another half of it.
Yeah, but is the half of 125 62.5?
Sure. Yeah, it is. It is.
Just wanted to see if I could do that. No joking.
No, it is.
Half it
No,
is
because you have to keep it, it's
62.5.
normal one, because that's one of the measurements, and you don't half it till the end. See, it's the 25 over radical 2, which is, if you take the shortcut, it's 125 radical 2 over 2 is the long sides. So that's what both of those sides is, so it's
Sorry.
basic,
But
so
then you
it's
have
125 times 125 radical 2 over 2.
Yeah.
And then you divide it in half, but then, are we keeping it in terms of radical?
Yeah, it's round to the nearest hundred.
Okay, so what, can you just tell me what the rounded to the hundredth is?
Of radical 2?
Yeah.
What was it? 1.4 or something? 1.4.
1.41.
something?
One
You have an answer?
I feel like this is wrong.
Okay.
But 150.89.
Nope. So remember, you're finding the area.
Okay, so I got this, I believe in myself.
Okay.
Okay.
What do you got?
Oh, I have to
and
math
then,
it still.
Oh, okay.
Can someone so can you give me a definite 1.4? I just,
You have
I
an
need
answer?
it solved.
This is gonna sound really dumb, but can't you just do 125 times 125 divided by 2? And then
Well,
you need to be in radical form.
because you still have to deal with the radicals.
But
So
then-
125 times 125, but it's actually 125 radical 2 over 2
That's what
times
I
125 radical 2 over 2 divided by 2.
Wait, that's the step I got stuck at. I was actually there, but I got stuck because I couldn't figure out the 1.4.
Yeah.
So if
radical 2, let's just find radical 2. So
Thank
radical
you.
2 is
I had it.
1.189.
I'm gonna just put it in my calculator. Okay.
Nope, I lied, sorry.
Great.
1.414.
Thank you. Okay. So it's 125 times radical 2. What is it? 1.41? 4.1?
So wait,
4.414.
I feel like this is still too low.
Yeah, probably, if you feel like it's too low.
Got 176.7.
75. Okay, times 176.75 divided.
So you're finding the area, not the perimeter.
It's just so hard.
Okay, I have a number.
It's just too many numbers.
I have a number. Tell me if it's right. Okay, I'm just gonna say it. Okay, 15620.28. Oh,
No.
are you sure? Are you like positive? No, I did
Well,
it.
let me think. Yeah, I'm positive.
Okay, no, because it's okay. It's the 176.75 is the it's because I forgot divided by, so you have to divide it by 2 again. You have to divide the 176.2 by
170. No, can you round it?
no, hold up. No, I believe in myself. Don't say anything. Please don't. Yeah.
Okay.
Because I know how to solve it. I swear I do.
That's too much.
Divided by 2. Okay. 88.2. Nope, that's not the answer.
No.
That's
So
only
that's
that's
one
only
of the
one of the
sides.
That's
sides.
only one, but do you have
And
to
then you multiply that by
Now you're halfway there. Now plug it into the formula.
Whoa. That's what I got to also, it should be said.
No.
Okay.
No.
So if you're doing this way, this is
It's at
probably
1,952.
No, I
Point something. No, because I divided it twice by accident because I zoned out.
How do you zone out?
Because you take
Wait,
away
11. How did I get 11,000? Wait. Yeah. No. Okay.
No. So
I don't
did you
know what I'm doing.
3,905.
There you go.
Oh my gosh.
Okay, so area.
Good job,
You
guys.
could do it this way, or you could just get rid of the radicalness right away and just get your 88.4.
I had that.
So area equals 88.4 times 88.4 because the base and the height are the same.
That's what I
all divided
did.
by 2.
That's what I did. And then that's what I did.
Okay, so then you get like 3905 or 3906-ish.
I should give Flack a
So-
time point for solving that. That should be said.
Good job, guys.
I got
That
halfway there. I'm gonna take half credit.
But I got the answer first.
Yeah, okay. I got that.
Let's just be clear.
Yeah.
I got it first.
Yeah.
Okay, let's go
Just get
move on to
past it
54. Well done. You guys are champs.
I'll get it next time.
All right, we ready? So this is lesson 54, and the title of this is Representing Solids.
That was not it. I solved the math. I no notes for that. Anyways, oh well. What's this lesson 54?
Okay, this is kind of cool. I like this chapter because if you're an artist, you'll kind of like this. You guys know what perspective drawing is?
No.
You took art class with
Yeah, for 2
We
years.
talked about
we were in the same class.
So when you look at a road, for example, if you look at a road on the like a highway that goes straight forever. Kind of looks like that, right? So you have like this.
I'm getting angry.
This is
Not at this, no.
this is a little.
Is this the last one?
So let's say we've got your horizon here. Okay. And then you've got like this crazy. You've got your road here. So see your highway? Here's your car. I don't know. I'm not going to draw a car. But I am going to draw. Just going to use green to draw the grass, okay?
Why do we need grass? So we're making a drawing.
Okay. And then here's my horizon. Okay. So really,
It's not a
if you look at a road, these lines are parallel. If you look at a road, correct? But from your perspective, these are not parallel lines, right? So this is called perspective drawing. So non-vertical parallel lines appear to meet at a point called the vanishing point. So this guy right here is called the vanishing point. I like the way they name it because it looks like these things are vanishing to a point. Okay. So if you look straight down a highway, it appears that the edges of the highway eventually come together at a point, but they don't, right? These lines will never intersect because they're parallel lines in reality, but from your perspective, they are not. If I'm looking at that door, what shape is that door frame?
Rectangle?
No, it's not. It's a parallelogram. It's not a rectangle. Those aren't right angles. Right? Because this is what I see. Okay? That's not even a parallelogram. It's like a trapezoid. Okay? This is the door frame that I see. This is my perspective. But is that a rectangle? Yes, it's a rectangle. Does that make sense? Because depending on where, so if Joe was looking at that, it'd look more like a rectangle. Okay? So depends on your perspective. All right, so if you have one vanishing point, this is called a one-point perspective. So one-point perspective is one vanishing point. Okay? So, for example, let's draw a shape. Okay? So here's a square, right? Now, when I pride myself in drawing like cubes and stuff for students who need a visual.
Oh, I'm really good at drawing cubes.
But this is not true perspective drawing, right? Because if you look at the square in the front and the square in the back, they're the same size. In reality, which one should be bigger, the front or the back? From your perspective, if you're looking at a cube.
What in the back?
Well, the back's going to be big. The back's going to be smaller because it's farther away, right?
Yeah.
So this is not true perspective drawing. This is a cool drawing, and this helps students visualize the three-dimensional part of it. But if I really wanted to make this more realistic, then it would probably look more like this. Where that square in the back would look a little bit smaller because it's deeper into your perspective. This literally looks like it's going inside of the board, and this one just looks like a cool drawing, okay? So a one-point perspective is just drawing any point, like for example, this one, okay? And then what I'm going to do now is I'm going to draw each vertex to that vanishing point. Okay, so far so good. And then what I'm going to do is I'm going to draw some lines here, parallel to the top, parallel to the bottom.
Oh, we did this in art.
Yeah. Yeah.
I gotta keep going.
Okay, so that looks more like this guy. See, that one looks more like this, where it looks like it's going more into the board. I should have drawn that point a little bit more this way because it looks a little wonky. But this is called a one-point perspective. Okay, you're going to be asked to draw these on one of your tests. Okay, so you just have to draw each vertex to this point. Okay, so step one, draw a square like we did and a horizontal line above it. So technically we should have drawn this horizontal line above it there. Okay, mark a vanishing point on the horizon. Doesn't have to be right above it, can be anywhere. Step two, draw a dashed line from the vanishing point to each of the four corners of the square. So I just drew a green line since that's about as good as the dashed line. Use the dashed line drawn in step two, draw the size of a similar square or a smaller similar square, okay? All right, so connect the two squares and erase the reference. So technically what we should do is we should erase these reference lines afterwards to make it look pretty. Okay? Still doesn't look as pretty. Bless you.
Thank you.
So that's a one-point perspective. Let's try a two-point perspective. Okay, so two-point perspective is you have two vanishing points. So two-point perspective. So here's a point here, here's a point here. And this is kind of cool. You know, like in TV shows where you see that corner store, or in Harry Potter, you know, the two twins who have that store now.
Yeah, yeah.
So the storefront that's on the corner, this is what this is going to look like. So watch this.
I have a question too.
Yes.
How do you draw a one-point perspective? Do you draw the shape and then do the lines up, or do you draw the lines from the shape?
So you draw the line and the shape, just the one-dimensional shape. So it was just a square in this case. And then draw a point, and then draw each corner or each vertex to that point.
So just draw a square first, and then a point, and then okay. Thank you.
Okay, now this is cool. Watch this. So this is how to draw something in two-point perspective. Are you guys done with your conversation? Because it's been happening for like 10 minutes. What are you talking about? I don't want to know. I don't want to know.
Actually, for a while we were talking about that. We were perspective drawing, and she was we were talking about this, and we were like, well, for a second we were like, this is what I'm learning in art, and then I learned about the vertex point, and then two-point perspective, and then I'm associating that.
So then what did that, I'm just curious, like what did that merge into? What kind of conversation?
Well, then I looked at her finger for a second, and I was like, oh my gosh, my friend has that ring. And then I got a little sidetracked, and then I got to look at my bracelet, and then Sorry. I can't see out of this eye. It's still like
I
pitch
just,
black.
no,
I tried to draw the 1-point perspective and it ended up ugly and it won't be nice.
okay, well, let's try it again after this. So this, you're gonna like this.
Why is that nicer than mine? Mine is so ugly.
So the first step to 2-point perspective is to the same thing, draw the line above. You guys got this line? And then I
Mine
want
looks
you
like a
to
sack.
draw a vertical line segment, just like I did here, below the horizontal line and between the two vanishing points. So it's
Okay,
got to be
I can
between the
do
2
this.
points.
I can
Okay,
do
you got
this.
that?
No, 1 second. 1 second. 1 second. Little arrow.
So now we're going to draw a dashed line from each endpoint of the line segment to the vanishing points.
Okay, let me.
This is already looking cool. So far, so good?
1
Now,
second.
since you don't have green, you can do a dashed line. Since Maddie can't see green on the video, this is going to look awesome, right? Because it's like drawing an invisible line.
Oh, that one was supposed to be dashed.
Yep.
It's not a great lesson for
So this one, so every time you see me draw green, you should be a dashed line.
So it's
Okay.
upsetting.
Now draw vertical segments between the dashed lines from step 1 as shown in the draw. So basically you're going to do this. You're going to draw vertical segments like this. Okay? You guys got that so far? And it doesn't have to be that close. It can be farther away if you want. Doesn't matter. Okay, and then you're going to draw dashed perspective lines from the segments to, you're going to draw dashed perspective lines to the, to each of the vanishing points above. Okay, so over here, you're going to do this. Bloop, bloop, and then you're going to go bloop, bloop.
Oh, okay. I'm sorry. So
Okay.
you draw from the base of the little up. Let through. I'm
Yeah,
so
so after
angry.
you draw these, you're going to do the same thing you did in the step 1 where you drew from each endpoint, you're going to draw to the vanishing points. So now that you drew those 2 new segments, you're going to do the same thing from each endpoint. Well, this one's already drawn from that endpoint, so you don't have to draw that one again, but you do draw that one. Okay?
This is making me.
You must have been really great in art class.
No. Well, see, here's this. I like this kind of art because it's calculated. Like you can calculate it.
Yeah.
I don't color outside of the lines. If you do that, you're a failure.
Sometimes I
Okay.
do that just to make people angry. Sometimes I'm like, what if I did it just to make people mad and annoy them?
Okay, so draw a dash line. We already
It
did
gives me
that.
power. I don't know.
Sketch the segments that make the top of the prism. So now we're going to sketch these segments. Boop, 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 boop,
What?
boop, boop. And then these guys in the back, these are in the back, so I'm going to do like a little dotted line there.
Okay.
So
Okay,
how many perspectives is this? Because
this is 2 perspective.
This looks like 10.
So this is 2 perspectives. So basically, here's that drawing. I erase the dotted lines. Then that's cool because this is like me looking at the storefront. Now here, let me draw the high angle of what is it? Fred and George,
I miss Fred.
his shop. Okay.
That's so sad.
So if I do it this way,
I just rewatched them over Christmas break, and I forgot how much I
Yeah.
drawn previously. Okay, that's my heart. Oh, wait. Oh.
so I'm doing the same thing. I'm just drawing the lines a little bit farther back. Okay. So, and they're not even, but that's okay. So then I'm going to draw my perspective lines again. Blip, blip.
This feels like an art class.
It does.
Okay.
I I solved my math problem for the.
So now when I draw the top of my prism, here's what it looks like. So it's line to line, line to line. And then this one back, or line to line. And then underneath here is this guy. It's a little off, but that's all right. Okay, so doesn't that look like a corner store? Okay, that's 2-point perspective.
Wow.
Okay, there's one more thing here. Isometric drawing is a way of drawing three-dimensional figures using isometric dot paper. Okay, so here's what isometric dot paper looks like. You've got 120-degree angles, 120 degrees, 120 degrees, 120 degrees. And then you've probably seen this paper before, but there's dots here. Okay, and then these dots, it's probably better to just show you on here. So I'm gonna share my screen here and then so you can see what's happening. 1 second. Almost done. Okay, so let's share up here. And I'm going to share for Tristan.
It's Tristan.
Okay, can you guys see this? Oh, you can't.
No.
Mirror.
Yeah, it's around 45, so we'll probably be outside.
Okay, so this is what that paper looks like. So you can see how you can create little lines over here. You can connect these lines to make three-dimensional. Do you see the cubes? Look at these three-dimensional objects. You see like a little cube here? But it's technically not perspective drawing, is it? Because it's not smaller when you get in the back. But you can connect these, like you could draw a cube right here down at the bottom left. You see those points there? You could draw a cube, but it doesn't get smaller in the back. Okay? So these are basically isometric drawing is a way of drawing three-dimensional figure using isometric dot paper, which has equally spaced dots in repeating triangular pattern. Okay? The drawings can be made by using three axes that intersect to form 120-degree angles, just like it's shown up there. Okay? So you can create these drawings pretty nicely, like right here. There's a nice little drawing here, a little brick or whatever that is. But see how they just connected the dots that are on that dot matrix paper. Okay? So all you have to do is draw three axes on the isometric dot paper if it's not done already, as shown below, and then use the vertex as the bottom corner of the prism. Draw the box so that the edges of the prism run parallel to the three axes. Okay, shade the top, front, side of the prism, and we'll add perspective depth. So if you shade it different colors, it adds more depth. Okay, so that's about it. That's all I got today. That's 54. Fun little chapter on drawing. Okay, you guys good?